requires precision. So, it has any rocket, if you want to launch something into the orbit, it has to be, the last stage should be liquid stage, so that we can control the fuel, control the amount of fuel burned, so that we can give a precise velocity to the orbit. Okay. So, that is how it is been done. So, PSLV, the main successful program of ISRO, I said it can launch up to 1500, and this also, please remember, the success is very important for India, because this will also, in the defense parlance, this will also provide India, okay, this will also, PSLV also provide India with ICBM status, intercontinental ballistic missiles, which can travel more than 5,000 kilometers. Okay. ICBM status, intercontinental ballistic missile status. So, successful launch of PSLV is automatically, even if we are not developing an ICBM, this if you have the capability to launch PSLV, you have the capability. So, you have the capability to launch ICBM. So, how this PSLV come back to earth? It will not come back to the earth. PSLV, once it is launched, this rocket is destroyed. We have to develop a new rocket. It is only one time use and throw. Okay, it will not come back. PSLV will not come back. Each stage will fall back and burn off and get destroyed. We are not using it again. Satellites will revolve around the sun. Satellites will revolve around the earth. That is okay till the designated time period. Anyway, so that is the situation as far as PSLV is concerned. And now, since PSLV more than 50 successful launches, sir, I watched on YouTube, not only the Indian, even foreigners also do not use this 13 number. कोई बात नहीं यार, foreigner use करे, so foreigner जो करता है वो सब हमें भी करना है क्या? So whatever superstition is there in foreigners, we should continue with that. तो इसलिए तुमको क्या खुशी होगी, वो भी मर रहे, मैं भी मर रहा हूं, तो तुम्हारा दोस्त रोहिणी, तुम भी तो रोहिणी, नाम ही तुम्हारा रोहिणी है, तो तुम्हारा दोस्त अगर जाके कोई कुएं में कूदा तो तुम भी कूदेंगे, वो भी कूद गया मैं भी कूद लेता हूं, क्या बोलेंगे वो एग्जाम नहीं लिखा मैं भी नहीं लिखूंगा? कम ऑन यार, फॉरेनर भी अगर मूर्ख है तो तुम भी मूर्ख है. Okay. So, let us not emulate foreigners. Foreigners have superstition, many superstition, Americans have many superstition, Britishers have superstition on 111 number. वो नहीं मानता है 111 में, वो लगता है कि they have a problem. In cricket आप देखना, say 111 is Nelson number, that's what they say. So, there are many such superstition. 111 for one, very dangerous, you may lose a wicket immediately, that's what they say. All nonsense yaar, come on. So, if foreigner believe हो गया तो तुम भी खुश हो गया. Okay. कोई tragedy नहीं है, कोई tragedy नहीं है. These are all superstition. All Rahu Kal, Ketu Kal. अरे every day is a good day. अरे every day is an auspicious day. हम लोग शादी के लिए भी time fix करता है. Only on this time we should marry. And then what happens? So many divorces. So if everything is so good, then divorce ही नहीं होना चाहिए था. So let us not talk about auspicious time, auspicious number, auspicious date, all nonsense. I mean, okay, if you believe, I have no problem, माफ कर दो मुझे. Okay, so so unnecessarily, you don't get into these things. You do your work. Okay, if you believe in God, pray to God, or if you don't believe, accordingly you do. You believe in your fate, whatever it is. Please do your work first. Okay, these numbers and all will not take you anywhere, or numerology, astrology. I mean, I have all, if you have faith, you please continue with that. You wear a stone, if you have faith, you please continue with that, but stone is a stone. Okay, anyway, let us not get into the detail unnecessarily. So, if you think 13 number is been believed by foreigners, we will not continue with that. I will not continue with that, please remember that. Okay, so I have no problem. So many people, even in the office say, if a batch is to be started, some people say, sir, Monday, Tuesday, Wednesday. I said, any day, yaar, come on. any day, any time. I never think whether it is a morning 10 o'clock should be the timing to start the batch or 11 o'clock, it does not matter yaar, come on. So, I mean if you believe, continue with your belief, I have no problem, but otherwise control. Okay. So, and if human beings go and come back, we will come to that. अब जाएगा तो वापस नहीं आता ना. If you have to go, then we need another vehicle. If we have to bring human beings back to earth in a launch vehicle, then the launch vehicle has to be different, because it has to come back. It's not that easy anyway. So, forget about that. Now, coming back to our discussion, PSLV of late we have developed many. PSLV has many variants. Okay. So, many types. So, one the original one called PSLV G, it was a generic type. This is the original PSLV, and the original PSLV, it had 6 strap-on motors. Now, it is strapped on in the first stage, okay, 6. To provide additional thrust. Okay. In the first stage, they add 6 more engines, small ones, but they are all liquid engines. The one is solid, the main engine is solid, but 6 strap-on motors or 6 liquid engines are also added. So, this is called with 9 tons or 6 into 9 tons of fuel each. Okay. And this plus the core, of course, so 6 strap-on motors, 6 more motors have been added, that is what the original version. Then we have the second stage, the third stage, then the fourth stage. Okay. The first stage solid, but it is adding to give more energy, more push, more thrust. You are adding 6 strap-on motors also, that is the original PSLV variant, that is called PSLV G today. Then came the PSLV, the latest, which has been and the last PSLV G, it is retired. So, PSLV G is no more in use, it is retired, and the last one was PSLV C35. Okay, PSLV C35 was the last PSLV, that generic variant. Now, then they have developed another variant called PSLV CA, called PSLV core alone variety. PSLV core alone, and the first launch, okay, the first launch was in 2007. Since 2007 we have this, and that means core alone, no strap-on motors. Normally PSLV core alone is used when the height and the payload is less. Okay, when height and payload is less. So, it can carry around say around 1100 kilogram up to 600 kilometers, but only no strap-on motors is called PSLV CA core alone, that is in 2007 we started. Then came PSLV XL, extra large. Okay, PSLV extra large. So, here we have all extra large means there are more weight. This is for our GTO, okay, when we are launching it to geostationary transfer orbit, we need maximum capacity. We have to take it to the geostationary transfer orbit. So, it has 6 strap-on motors, but with additional capacity. So, these are bigger ones. So, 6 into 12 tons of fuel. Okay, strap-on motor, bigger strap-on motors. Earlier I said 9 ton, now it is 12 tons, and this is called this is first XL was used in Chandrayaan 1, PSLV C11, PSLV C11, Chandrayaan 1 mission. This XL was used, okay, and that was in 2008. Okay, this was in I think 2008, PSLV C11. So, additional capacity, that is why it is called PSLV XL. Now, we have also developed another one called PSLV DL. Again, it depending upon the capacity. So, it has 2 strap-on motors, just 2 into 12 ton strap-on motors in the first stage. It has 2 strap-on motors in the first stage. Okay. So, again depending upon the requirement we are doing it, and also now we are developing PSLV C11 is on 2005, I do not think so, man. I mean, you please cross check, and it should be in 2008, not in 5. Okay. Chandrayaan was in 7, 8, I remember that. Okay. So, anyway, PSLV C11, D11, is a DL, sorry, PSLV DL. Then now we are also developing another one called PSLV QL. Is a new one under development. 4 strap-on motors into 12 tons each. Sorry, that is already there, not under development, we have already used, that was in PSLV C45. Okay, we already have PSLV QL. So, it only difference is in the strap-on motors, whether it has there or not. Generally it was 6, now a core alone version is there, only 2 strap-on motors, 4 strap-on motors. So, we have developed different ones depending upon the requirement. That shows our mastery in the whole area, whole in a PSLV launch. That is why we are having all these different variants. Now, we are developing another one called in a PSLV 3S, it is only in the concept stage. Which is going to be for smaller satellites up to 500 kilograms up to 550 kilometers. 500 kilograms up to 550 kilometers. This is going to be a 3-stage PSLV, a 3-stage PSLV. So, the 6 strap-on motors plus the second stage Vikas engine will not be there. Okay, 6 strap-on motors plus second stage Vikas engine not there. The 6 strap-on motors plus second stage Vikas engine not there. That is 3S. We are planning in future smaller satellites up to 550 kilometers, strap-on motors plus the second stage not there, that is the 3S model which we are talking. Anyway, so these are some of the PSLVs, but I have said PSLV is for polar satellite launch vehicle from pole to pole, normally for remote sensing low earth orbit, but we can also use it for GTO, geostationary transfer orbit, up to 1500 kilogram weighing satellites can be launched into the GTO. So that is also possible. So that is the PSLV, our main workhorse, and I said PSLV C51 was the latest, is it not? PSLV C51 was launched in February 2021, okay, and that Amazonia. PSLV C51 was launched. Before the PSLV C50, we launched a CMS-1. That was into GTO. C50 was used for launching into GTO. This is for polar sun synchronous orbit, PSSO. This is for GTO. Then C49 for Earth observations are EOS-1. It was a PSSO, polar sun synchronous orbit. 49 was launched in November 2020. This was in December 2020. Just see. December 2020 is November 2020. And 48 RESAT 2BR1. Again a polar sun synchronous orbit. And C48, it was launched in December 2019. So these are some of the latest PSLVs which we are launched, all of them successful. Only one unsuccessful one recently after many years, that was that PSLV C39, okay, that IRNSS1H, the last unsuccessful PSLV. PSLV C39, it was in August 2017. Among the C series, after we start the commercial launch, the first unsuccessful one was PSLV C39, unsuccessful, failed. After that again we have launched 11 of them, all successful, no trouble. So PSLV is one of the most reliable launch vehicles in the world today. Even NASA cannot claim such kind of a success rate. Among the 51 satellites, I mean in the C series, probably 50 we launched because 13 we did not launch, only one if it failed, only one failure. It is huge. In 50 launches, if only one failure, definitely it should be considered as a very good success rate. Anyway, so that is the situation PSLV C39. Okay. So that is about the PSLV. Now, let us move into GSLV. Okay, this is about the PSLVs, whatever is required, I think I have covered it. Now, coming to GSLV, geostationary satellite vehicle. Geostationary satellite launch vehicle. So, here we have to launch satellites to GTO. I already mentioned this. Geostationary transfer orbit, and we have to place heavy satellites. So, here we are looking at launching satellites 4 to 5 tons weighing satellites into GTO, so that it can be acting as communication satellites for us, even weather forecasting satellites, plenty of application. Now, GSLV, which we started developing, is a 3-stage vehicle. Three-stage vehicle. And first stage is solid. Again, as usual, as I mentioned, first stage has to be solid, second is liquid, and even third has to be liquid, there is no choice. So, our GSLV has a solid, liquid, liquid stages. That is how it has been developed by our scientists. And the first stage, okay, the first stage GSLV is a 3-stage, almost 49-meter tall. And the total lift of weight is 401 tons. Okay. And the first stage is a solid propellant 120 S125. Okay. The first stage is solid, called S125 engine, around 125 ton weighing, and 4 liquid propellant strap-on motors. Of 40 tons. Okay. So, this is our GSLV. The right now which we call it as the 3-stage vehicle, it is the original one which we developed is known as GSLV Mark II, MK2. GSLV Mark II is the present one which we are using, and this MK2 Mark II has 4 strap-on motors. The first stage, first stage is solid S125 engine, around 125 ton weighing, plus 4 liquid strap-on motors of 40 tons each, and it is known as L40 strap-on motors. L40 strap-on motors, and the fuel, it is, since it is solid, the solid fuel, it is same HTPB, similar to our PSLV HTPB, HTPB based hydroxyl terminated polybutadiene. Hydroxyl terminated polybutadiene is the fuel here also, in PSLV's first stage also. So, there is no change in that. So, around 125 plus tons of solid fuel, 40 tons of liquid fuel here, and that is the first stage, similar to, first stage is similar to PSLV, but a bigger one. but 4 strap-on motor. In the original PSLV, the generic version, 6 strap-on motors were there, here 4 strap-on motors to give strength and thrust to the first stage. Then comes the second stage. It is again similar to Vikas engine, liquid fuel, and it is around 37 tons. Second stage, the fuel, and it is UDMH, unsymmetrical dimethyl hydrazine, plus N2O4 nitrous oxides. Okay. So, the fuel is unsymmetrical dimethyl hydrazine, again similar to our PSLV. In PSLV, second stage was UDMH fuel. So, same thing. So, UDMH plus N2O4 nitrous oxides, this is how this has been with the second stage Vikas engine, similar to the second stage of the PSLV also. Then comes the third stage and last stage. Third stage, the last stage, see, this is where the GSLVs are totally different from PSLV. The third stage, that is the most crucial stage, most difficult stage. Okay, most crucial and most difficult. The third stage and the last stage is the most crucial and the most difficult. This is called the cryogenic stage. The third stage of GSLV is known as the cryogenic stage. Cryogenic engines are used here. Cryo means very low temperature. Very low temperature, cryo. And why very low temperature? Here we want the best fuel, we want the maximum fuel efficiency is required. Because we want maximum output with the minimum fuel, maximum output with minimum fuel. That is the purpose. That is why cryogenic engine. So, why? So, to have the best fuel, the best efficiency, scientists have found that the best efficiency among all the liquid fuels, the best efficiency is in liquid hydrogen. It has been found that liquid hydrogen has the best efficiency, but the problem is liquid hydrogen, we can convert hydrogen into liquid stage. Only at liquid hydrogen we can get it only at minus 253 degrees Celsius. And to burn this liquid hydrogen, we need to provide liquid oxygen, but that we can get at minus 196 degrees Celsius. So, you can imagine, to provide fuel at that temperature. Okay. That is why we call it a cryogenic engine. When it burns, it will provide maximum energy, maximum efficiency, but we have to store the fuel at such temperature. That is why, because we are using liquid hydrogen, we have to use liquid oxygen also as an oxidizer, and then the engine is called cryogenic engine. Cryogenic means an engine which is using liquid fuel at a very, very low temperature, and the very, very low temperature we know it is minus 253 degrees Celsius. So, that is the complexity in the cryogenic engine, and the problem in cryogenic engine is it's the fuel tank is a problem, because how to store fuel in such a low temperature, even the casing, the cracking, it may crack, because even the steel at low temperature it may behave differently. So, fuel tanks may crack, then even the pumps to from the fuel tank, the turbo pumps are there to push this fuel into the engine. So, how the pumps will work, because one side is very low temperature, on the other side of the engine it is very high temperature. See, the problem is on one side of the pump it is minus 253 degrees Celsius, on the other side it is 700 degrees Celsius, because in the engine the temperature may be up to 700, 800 degrees Celsius. So, the difference in temperature on either side of the pump is almost 1000 degrees Celsius or 800 degrees Celsius. So, how to design the pump? So, all these are the challenges in the cryogenic engine. In 1990s, when India started developing, our scientists realized the difficulty. So, we decided to outsource it. We decided to outsource the cryogenic engine. In 1990s, and we floated a global tender, and we managed to get the best deal from the Russian company called Glavkosmos. Glavkosmos of Russia agreed to supply 7 engines. Sorry, initially they agreed to supply 3 engines plus technology. We wanted the technology, complex technology. So, we went for a global tender. Glavkosmos of Russia and even Ford of US and many companies participated. Finally, we awarded this technology to Russia. Once this was awarded and they even started supplying some technology, at that time it was in early 1990s, immediately after the collapse of the Soviet Union. Okay, immediately after the collapse of the Soviet Union, they were dependent on US for their survival, and the US put pressure. Now, after everything is over, even US companies participated in the the tender, and our relationship with USA was not good. We were not in the good books of the US at that time. In early 1990s, the US objected, because they started saying that this cryogenic engine technology, if it is given to India, India will develop, be used for intercontinental ballistic missiles and things like that. The USA objected, the Russia backed out because of the pressure at that time. Russia backed out because that is the time Russia just came out of the collapse of the Soviet Union. They were dependent on the US for their survival, and Russia could not withstand the pressure of the US, and Russia backed out of the agreement. But we renegotiated. Why? Because we have already paid some money to them, and Russia was not in a position to pay back the money and all. We renegotiated we renegotiated, and Russia agreed to supply 7 engines, but no technology. Russia agreed to supply 7 engines, but no technology. 6 plus 1, basically 1 prototype type and 7 engines were given, total 7 engines were given. So, because of the Russian backing out, Russia backed out of the agreement in mid 1990s, we started our indigenous cryogenic engine development program. Subsequently, our indigenous cryogenic engine development program began. I hope you are getting the sequence. So, that is how, so cryogenic engines are a must for geostationary satellite launching. For bigger because that third stage, the last stage should provide maximum thrust, minimum maximum efficiency with the minimum fuel. So, the cryogenic engine are of around what you call CE 7.5 tons. The Russian cryogenic engines are cryogenic engines of 7.5 ton fuel, okay, 7.5 tons. So, it started with first stage, I am repeating, we have a solid 125 plus 4 into 40. Then second stage, it is Vikas type engine, I think 37.5 tons. Then third stage, cryogenic engine of 7.5 tons. So, total almost around 400 tons, okay, 125 plus 160 plus 37.5 plus 7.5. So, 14, 15, 20, 6 plus 3, 9, 9 plus 2, 11, plus 2, 13. So, this is coming to only around 330 plus the rest of the weight. So, the fuel weight I was talking, the rest of the weight will add up to around 400. Okay. So, this is anyway, do not get into the calculation and all, do not confuse. So, but this is how the whole thing. Okay. So, this is the situation. This is the situation. So, this is called GSLV Mk2 Mark II, okay. And we started our GSLV program by using the Russian cryogenic engines, okay. We started our GSLV programs using the Russian cryogenic engines, okay. And the first launch was GSLV D1, okay, in 2001. We got 7 engines. So, in this D1, first 2 stages are Indian and the third stage is Russian, okay. Russian cryo. It was partially successful, okay. Russian cryo, we can say it was partially successful, and we launched GSAT-1. It is not fully successful, partial, because it reached the orbit, but it could not, but some issues were there. So, that is why it is partially successful. Then came GSLV D2, these are all development, D for development, and we launched in 2003. So, second, so 1 Russian cryogenic engine, 2 second Russian cryo used, GSAT-2 successful. So, GSLV D2 was successful in 2003. We have celebrated, maja aa gaya. Immediately, since it was successful, because we have only limited cryogenic engines with us and we have to use the Russian one, 7 only we can have, because that is the agreement, the rest we will have to develop by ourselves, then only we can continue. We can do some reverse engineering, we can do some, by looking at that we can develop, but it takes time. So, GSLV. Now, immediately after D2, since it was successful, we launched our functional first one, F1, a commercial launch in 2004, and we launched, so the third Russian cryo was already used, and we launched our EduSat for education purpose, okay, and or it is also called GSAT-3. So, the first commercial application for education purpose launched from India was EduSat in 2004, okay, GSLV F1, it was successful. So, we were very happy, maja aa gaya, hame samajh mein aa gaya. So, but we know even recently, a couple of weeks before what was launched in 2021, it failed. So, that is why GSLV is still problematic for us. So, F1 was successful. So, immediately we decided to launch GSLV F2 and INSAT 4C. At that time INSAT series were still going on. So, this was in 2006. So, the fourth Russian cryogenic engine used, but unfortunately it failed. So, in 2006 GSLV F2, the fourth Russian cryogenic engine, it failed. So, immediately we decided to launch a replacement for 4C. So, GSLV F4, F3 was not launched. So, we named it as F4, and it was in 2007 INSAT 4CR, the replacement for 4C, fifth Russian cryogenic engine. देखो सारा खत्म हो रहा है एक एक करके, okay, fifth Russian cryo used, very significant. That is, I am just counting, we have only 7. So, GSLV F4 was successful, we launched, we managed to launch it, so we could replace, so successful. That was in 2007. Now, we have only 2 more left and our Indian cryogenic engine was not ready. So, we were in a dilemma what to do. बहुत मेहनत किया, हमने सोचा कि हमें we have to save our cryogenic engine. So, in the Russian cryogenic engine. So, from 2007 there is a long gap because our indigenous cryogenic engine was not ready. Finally, in 2010 हम तैयार हो गया GSLV D3. See, please see the first 2 development flights D1 and D2 Russian, and then once we were confident that we said that F1, F2, F4, so 5 Russian cryogenic engines used. Now, the D3 has come back once again, that was in 2010. The first indigenous or Indian cryo. So, by this time, by 2010, we developed our own cryogenic engine, the Liquid Propulsion System Center in Thiruvananthapuram, and they have tested at Mahendragiri, the test site in Tamil Nadu, across Thiruvananthapuram in Kerala Tamil Nadu border. That is where the testing, everything was done. D3 2010. So, and it was a failure. The first indigenous cryogenic engine, it once again it failed. So, luckily we have not used the Russian cryogenic engine. So, D3 maaf kar diya. Then we decided to launch GSLV F6. Ab dekho khel GSLV F6 again in 2010 itself, okay, in the month of December, the end of 2010. Now we decided to use the Russian cryogenic engine, the 6th Russian engine or cryo, and we were launching GSAT 5P. So, the GSLV D3 it failed, no problem, and the GSAT 4 was there anyway. So, this GSAT 5P was the name given, it was for telemedicine purpose and all. GSAT 5P in 2010 it also failed. Now onward the failure sequence. So, you just see how many failures. First one was partial, no problem. 4C failed, is it not? 4C failed, then D3 failed or rather F2 failed, D3 failed, F6 failed. So, in 4 launches 3 failures between 2006 and 2010, 4 launches and 3 failures. So, again it shook the confidence of ISRO when it comes to GSLV, that was in 2010. Then again long wait, because we have only one more engine, 6 engines we already use, 1 prototype is left, we cannot use anything else there. So, we have then the next launch GSLV D5, again D4 is not there. So, numbering आपको जरा ध्यान रखना, D4 के बाद sorry D3 then D5, that was in 2014, after 4 years now, once again long gap, and GSAT 14 it was successful. So, D5, this is an D means Indian cryogenic engine. So, please note GSLV D5 2014 was the first successful Indian cryogenic engine. Okay. GSLV D5 2014, GSAT 14 was launched, the first Indian cryogenic engine. So, fully indigenous successful GSLV was in was in 2014 GSLV D5, because here it is everything, no Russian involvement here, and it was successful. Then came GSLV D6. That was in 2015, again successful. So, हम लोग confidence वापस आ गया. Then we have launched GSLV F5. So, then F9. So, then came once again F series, F5, F9, then F8 also. So, we managed. So, then F11. So, all we launched in between 2015 to 2021, but finally once again GSLV F10 EOS 3 Earth Observation Satellite 3, which we launched on August 12th 2021, failed. So, please remember the latest failure is GSLV F10 EOS 3 August 12, 2021, it failed. So, once again there is a GSLV failure, that is the MK2 series, Mark II series. Okay. So, that is how it has been done. So, there are some glitches even in this failure. What happened? The cryogenic engine failed to ignite. After the first two stages, the third stage failed to ignite, and that is how the whole thing came back to Bay of Bengal. So, there was a failure in on August 12th, 2021. So, this year, so that is a problem, that is an issue. Okay. So, that is what. Now, ISRO meantime, we have also developed a new series of GSLV called GSLV MK3 Mark III. Okay, GSLV Mark III. So, here the design, it is a fully indigenous, no Russian baggage. Can we get question related to failure? I do not know, but if a question is asked regarding GSLV and F10 in the 4 options in preliminary, there can be failed, successful, all those questions can be there. So, that is how you should be knowing it. Okay. So, yeah, we are with only one Russian cryogenic engine, and that we have not used, that is a prototype, that is to be, that is a model, we have kept it, we have not used it. So, MK3 is a new, a fully indigenous version with enhanced capacity, and this can launch 4 to 5 tons satellite, okay, 4 minimum satellites to GTO and 10 tons to LEO, low earth orbit. So, it is a massive one. So, GSLV Mark III is a massive one. We have capacity to launch 4 to 5 tons to GTO and 10 tons to LEO. So, it is almost twice the capacity of Mark II. Mark III has twice the capacity of Mark II, and the design is totally different. So, the design is very interesting. It has 2 engines in the first stage. Okay. And it is in between this is called a 2S200 solid stage 200 ton fuel, then second stage then cryo. So, something like this. So, 2 solid stage solid state or solid fuel first stage, 2 into 200 tons solid fuel first stage. Okay. And this will be fired, the first stage, this will be fired for 140 seconds. So, it will burn, it will complete in 140 seconds. First stage will be completed in 140 seconds. And then we have two clustered, sorry, Vikas liquid engines of L110. Okay. So, this second stage is divided into two, or rather two of them. Second stage is called L110. So, two Vikas engine modified ton liquid engines as the second stage. And this is called two clustered Vikas liquid engines, two clustered Vikas engines. So, double engine, like a double engine Sarkar, that is what they always claim na, Modi ji in Delhi and Yogi ji in UP, double engine Sarkar, same thing, two clustered Vikas engine. Okay. So, double engine in second stage and L 110 tons each, or liquid stage 110 each, and it will start ignition, or will ignite at 114th second. At 114 seconds of the lift off, the liquid stage will start getting ignited. And the first stage will get separated at 140 seconds. At the end of 140, the first stage will fall off, then the second stage will fully. So, there will be a stage when the first stage as well as the second stage will be ignited together, okay, both will be burning. So, that is the time when maximum thrust will be given, okay. And then the third stage is a CE, third stage, CE20, cryogenic engine stage, third stage, 20 tons. See, in the Mark II, it is just 7.5 ton, it is 20 tons, almost 3 times bigger. So, CE 20, that is the cryogenic stage. Okay, it is a cryogenic stage. One second, and they are 25. So, they call it a cryogenic upper stage called C25. Okay, CE29, C25, and the cryo stage. Sorry, C25 or CE20 engine, CE20 engine, and more than 25 tons of fuel. Okay, CE25 engine, sorry, CE20 engine with 28 tons of fuel, hydrogen plus oxygen put together is 28 tons. Anyway, let us not get into the details of that. So, CE20 engine, CE20 engine or C25 cryogenic engines in the last stage. So, please see, if the design is totally different, two solid state boosters in the first stage, then two liquid engines in the clustered one in the second stage, and then the third stage is a cryogenic engine, which we call it as CE20 engines. This is L110, this is S200, solid stage, then liquid stage. So, no cryogenic engine of Russian model, it is indigenous model, we have developed it indigenously, almost 3 decades of our research has finally resulted in having a cryogenic engine of our own version. It is nothing to do with Russian engine, Russian design. Okay. So, that is how we have developed this 3-stage vehicle, totally different from the previous designs, and the satellite will be kept. It can carry around 4 to 5 tons of weight. Okay, 4 to 5 tons of weight can be carried. So, that is how this has been developed, and the first Mark III, okay, the first Mark III design was first test was there called GSLV Mark III in December 2014. GSLV Mk3 December 2014, but this was only a 2-stage experiment with no cryogenic engine. So, cryogenic stage is called CE20 and the engine is called C20 sorry अब फिर आप confuse मत करो दोबारा मैं बोल देता हूँ it is both the names are used. Okay, cryogenic upper stage, okay, cryo upper stage is known as C25, but the engine is known as CE20. Okay, engine is known as CE20 and otherwise it is generally called cryogenic upper stage or C25 stage. Okay. So, anyway, so let us not confuse here. So, this Mk3's first test was in 2014, Mark III 2014, but it was only 2 stages, the third stage is not tested at all, there is no third stage in that. So, but then we came the GSLV Mark III D1. In 2017, we launched GSAT 19, successful. Our Mark III, the first launch was successful. GSLV Mark III D1 2017 successful. Then came GSLV D2 Mark III D2 GSAT 29 again successful. GSAT 29 in 2018 successful. GSLV Mark III D2 GSAT 29 successful. Then came GSLV Mark III Mk3 M1. Okay, now a new series for commercial launch. 2019 we launched our Chandrayaan 2. Chandrayaan 2, see, as far as the launch is concerned, it is successful. Of course, we could not land it properly in Chandrayaan, otherwise 100% we will say it is successful. So, we will say this is successful because we could launch it properly. Only during the descent on the surface of the moon there was a failure in the last 2 minutes. So, GSLV Mark III M1 2019 100% indigenous, nothing to do with the Russian model, Russian design. Okay. So, this was in 2019 it was successful. So, we have launched 3 GSLV Mark III engine or Mark III missions D1, D2 and M1. Please note 2019 Mark III M1 it was successful. But recently what has failed was GSLV Mark II F10. Okay. GSLV Mark II F10 August 2021 failed. I hope now you are able to make the difference. We always had this problem with the Russian integration into our Indian system. So, it has failed once again. So, it is a blow to our, definitely any failure is a setback, but the best thing is we are not that relying on this Mark II, because we have already developed Mark III, and if you are going ahead with Mark III, then there will not be any problem. So, that is how this the Mark III situation is right now, and we are moving ahead with Mark III and we need not worry. So, F10, yes, it is a failure, it is a Russian design. Mark II has a Russian design, but the new generation one is already in the pipeline, but we were planning many new launches using this Mark II F series during 2023-24. We were planning many Mark II launches. So, this failure of F10 is a setback. But the good thing is we are not dependent on Mark II, we have already developed Mark III, we have already done the first successful mission in the Chandrayaan 2. So, that way that may not be that bad, but the launches we planned using Mark II for 23-24, especially after the pandemic when we thought that we are back on track. So, this is a big setback. We will come, because again in Mark II, that F10, the third stage did not get ignited on time and the whole thing failed and fell into the Indian Ocean. So, that is what this has happened. Okay. So, the cryogenic stage, I already said that. So, cryogenic stage is there in both. Mark III is a bigger one, almost 3 times bigger than the Mark II, and overall capacity of Mark III is almost double that of Mark II. So, it is a huge advantage or huge step forward. So, that is how the GSLVs are placed. So, I will stop here today. In the next class, whenever my schedule is there,